physics pop quiz, which was related to the refraction of the light. And this was a pop quiz too. And the first question, in an experiment to determine the refractive index of the glass, a student directed a ray of a light towards a glass prism. The ray of a light is shown before and after it is entering. Determine the refractive index. The angle with the surface is given. So what we have to do, we have to draw a normal. The normal should always be perpendicular. So if the angle with the surface is 32, what will be the remaining angle? Because the total sum with the surface to the normal, it should be 90. So this angle will be 58. And here, if this angle is 50, so or what should be the remaining angle? Remaining angle should be 40. We use the Snell's law, n1 sine theta 1 equals n2 sine theta 2. N1 is a refractive index of the first medium because it is traveling from air to glass. So refractive index of the air is 1. Sine theta 1, this is theta 1, which is 58 degrees. Your calculator mode should be in degrees, not in radian, when you're solving this question. So for a light question, whenever you solve, the theta should always be in degrees when you substitute in this Snell's law. So when we divide sine 58 over sine 40, that will give us a refractive index of this material, which is 1.32. Draw on the diagram the ray of a light as it emerges from the prism. No further calculation, so we don't have to calculate. What you have to do, you have to draw a normal. And normal is always perpendicular to the surface. So if this is a surface, so this will be normal. We don't need calculation. We just have to show as the light travels from glass to air, the speed increases. So it will bend further from the or away from the normal. A different prism is made of refractive index 1.63, the speed of a light in this. How 3 marks for the first question? 1 mark is for writing the Snell's law. 1 mark is for the angle of the incidence and angle of refraction values, and 1 mark is for the final answer. That's how the marks are distributed. A different prism is there with a refractive index of 1.63. Calculate the speed of a light in a glass. So how to work out the speed of a light in glass? So we have n1 sine theta 1 equals n2 sine theta 2. Or this is a Snell's law. In terms of speed, we have the formula n1 over v1 or n1 v1 equals n2 v2, because the speed and the refractive index are reciprocal. So n1 is a refractive index of air, v1 is the speed of light in air, n2 is a refractive index of the second medium, and v2 is the speed in the second medium. So if we need v2, just 3 exponent 8 divided by 1.63, the refractive index of this medium, we will get 1.84 into 10 to the power 8 meter per second. That's v2. In question 2, a ray of a light approaches a boundary between air and a glass as shown. Which of the following statement about the total internal reflection is correct? So total internal reflection, when the light bounce back in the same medium, when this angle of the incidence is more than or greater than the critical angle. So a ray of a light passes, angle of incidence I is there. Which of the following statement about total for the ray of a light at a boundary? The light is moving from air to glass. But what is the condition for total reflection? The light should strike denser to rarer boundary. Like light is moving in a denser medium and it strike a rarer boundary. So when it strike denser to rarer boundary, then only total reflection. So here the light is moving in air and striking a glass. So in this case, the total reflection cannot take place. It is impossible because for a total internal reflection to happen or occur, the light must strike the denser to rarer boundary. But here it's striking rarer to denser boundary, or light is moving in a low density medium. Then reflection can happen, but not the total internal reflection. The diagram shows a refraction of a light as it passes in three transparent material, L, M, and N. So first from L to M, what happened? The speed decreases because it bent away from normal. And from M to N, the speed increases as it bent away from the normal. So first speed is decreasing, then the speed is increasing. Which of the following relation between the speeds are there? So when you compare the deviation, the amount of deviation also, if you see the change in the angle, here there is a greater change in angle. You can use a protractor to measure this as compared to here increase in the angle. Because greater the change in the angle, greater the change in speed. So when the light was moving from L to M, there is a greater change in the angle. So means as compared to when the light travels from M to N, angle changes but small comparatively. If you measure using a protractor, draw the normal, you will find that this change is relatively smaller as compared to this one. So what it shows the light is traveling much faster. The slowest speed should be in M. And so slowest speed is, so which one, the M is having the slowest speed? That is the last one. So speed of a light is greater in L than N, and N it is greater than M. So M is having the slower speed because as it bent towards the normal from moving from L to M, and then it bent away from normal. So it shows that it was traveling much slower in M. Which of the following could result in a ray of a light undergo a total reflection? Total reflection, it should travel from denser to rarer. So when it travel like strike the M to N boundary, denser to rarer, then only it can bounce back. So traveling from M to N can lead to a total internal reflection. So C should be the right answer for this. Question 4, light is transverse. Describe the difference between a transverse and longitudinal. In a transverse wave, the vibration of the particle perpendicular, where in longitudinal it is parallel to direction of the wave. Two prisms A and B made from a different types of glass are placed in a contact, as you can see. State why the incident ray of light does not change the direction. Look, when the ray of a light is passing along the normal, the angle of the incidence is zero, so angle of refraction will also be zero. It will change the speed, but it will not change the direction. So you will mention angle of incidence is zero, so angle of refraction should also be zero, or it is passing along the normal. That's the reason. The next is the refractive index of a glass prism B is greater than refractive index of A. when the ray of a light reaches the boundary between some of the light is reflected and some is refracted. Complete the diagram to show two paths taken by the reflected and the refracted until they have returned to air. So what will happen? Because, and they mention here that for A, like prism B, and the refractive index of which prism is greater, refractive index glass prism B is greater than A. So the refractive index is greater, so speed will change greater. So draw the normal. This will be the normal. Normal is always perpendicular to the surface. So because it is moving in a denser medium, so it will bend towards the normal. But it should bend towards the normal in B. And then it will moving from, this will bend away from normal. If you draw the normal here. Then what will happen for prism A, there's a partial reflection is also there. Some of the rays reflected. But we cannot say it's a total reflection because it should be in a denser medium. So some of the rays reflected. And it is, when it is reflected, because this is a very large angle. If you see, and usually for the like 42, usually 42, 41 is a critical angle. So this angle here appear to a bit greater than the 42, so it will undergo a total internal reflection here. And then eventually it will leave. So if you leave this ray from here, like moving from glass to air, bend away from normal, you will not score the mark. Why? Because usually for glass 40, like you can take as an angle at which the total reflection can take place. So this angle is appear more than 40. Even you can measure this, you will work out that it is more than 40. So that's why we did not, the ray did not emerge from this point. It should to undergo a total reflection and then emerges from the other point. So these things, small points you have to keep in mind when you are completing a ray diagram or completing a path of the ray. Then calculate the angle of a refraction. So as a light travel, the refractive index of the two are given. Here from one prism to another, so we'll use n1 sine theta 1 is equals to n2 sine theta 2. And you can measure this angle. Like what you can do, you can measure the angle of the incidence from, draw a normal here and measure this angle. This will be theta 1. And then use a formula n1 sine theta 1 equals n2 sine theta 2. So refractive index for two types of glass A and B are there. Theta 1 we will get from our measurement. This is n1 sine theta 1. So we'll get them from measurement, so we can work out theta 2. The light emerging from prism B is observed through a polarizing filter. The polarizing filter is rotated gradually and the light transmitted from the filter vary the intensity. How this observation demonstrated the light was a transverse? Because polarization is actually a characteristic or a property of transverse. Longitudinal cannot, so light which is emerging out is polarized, and how we can conclude it is a polarized light? Because transverse waves can only be polarized. So light was a transverse, because what actually happened, the light which is emerging out, when we place a polarizing filter, If the planes are parallel, it allow that. But if we rotate the polarizing filter, then there is no light. So what this give an idea? This give an idea that light which is emerging out is a polarized light. And polarization only happen for transverse wave. So polarization can only happen or occur for transverse waves. Longitudinal waves cannot be polarized. Is it clear? This one, the pop quiz 2, which was related to the refraction of the light. Any question or a doubt in this?